Hey, Mr. Tallman here. We're going to be going over um, the Unit 6 review, questions 2 and question 4. Okay, so take a look at this. Here we have question 2, and we're trying to match each one of these graphs with their functions. Okay, now if I look at the basic equation for an exponential function, exponential because the variable is up here in the exponent, each one of these letters means something different, right? This letter A is our y-intercept, also known as our starting value. Right? So this is where our graph starts usually, or where it crosses the y-axis, right? This one here. This number, B, is how much it's changing by. So this is my rate of change. This is where you would put like percentages and stuff like that. Or if it's doubling, it would be like 2 right there, or something like that. If it's going up by 5%, it'd be like 1.05. Or if it was going down by 5%, it'd be 1 minus 0.05, which is 0.95. Okay? So when we look at these graphs, I notice that A and B both have the same y-intercept right here at 70. Okay? And C and D have the same y-intercept at 20. Right? So that means if I look at their equations, these two must be C and D, and these two must be A and B. So which one is which? Well, this one, oh wait a second. Let's go with the 21, right? One that start at 20. Okay, so this one's going up 1.25, and this one's going up 2. So this one's going up faster, so it must be like the steeper graph. Okay, so if I look at this, C is clearly steeper than D, so the steeper one is C, and the less steep one is D. All right, now it's kind of backwards because these two numbers are big, right? And this one's bigger, so it must be steeper. But when you're going down, so notice how A and B are both going down, the bigger number is less steep than the smaller number. So like the closer this number gets to 0, the steeper the graph goes down, the faster it goes down. So for instance, this one right here, 70 times 0.5, that number is smaller than the 0.8, right? So if I look at this, B is clearly going down faster than A. So that means this one is B, and this one is A. Okay? First thing to look for, though, is the y-intercept. Then you can look for the rates of change. Okay? All right, moving on. Number 4. All right, this one's a little bit more complicated. Um, we already know what the starting value is. We already know what the rate of change is. The thing that's weird about these is that the exponents are either a fraction or it's like a doubled number. So whatever the number is, we're going to times it by 2, right? So how many does each species start out with? Well, that's pretty easy. That's this A value, y equals A times B to the x power, right? This is my starting value, right? And in this case, it's 500. So both of them start with this first number. All right, which species is growing more quickly? Support your answer with math or words. So you can do this 2 ways. You could plug both of these into a graph, right? Or into Desmos, right? And then you could look at them and see which one's going up faster. And once you figure out which one's going up faster, which one's steeper, you need to explain to me on the paper, I used Desmos, or I graphed it, and species B was clearly steeper than species A, so species B is increasing faster. The other way to do this is to take a number, any number you want, and plug it in where this t is, right? Because t in this case is the number of days, right? So let's say we use 2 days, right? So t equals 2, right? For species A, all I have to do is go 500 times 2, and then instead of t, I'm going to put a 2 in there, to the 2 over 4 power. Well, 2 divided by 4, that's just 1/2, right? Or 0.5. So this actually equals 500 times 2 to the 0.5 power. All right. Now, if I do the same thing for b, and I plug this 2 in there, I get 500 times 2 to the 2 times t power. Right? So I'm just plugging in 2 where t is, right? Okay. Well, 2 times 2 is 4. That gives me 500 times 2 to the 4th power. I can already tell that b is going to be bigger because this one's only going up to the 0.5 power, and this one's going up to the 4th power. So whatever this is down here, we're going to multiply it by itself 4 times. This one down here, we're actually going to take like the root of it. So it's going to be like way different than what it is right now. Okay, so this one is definitely going up faster. You could also put those into your calculator and they would give you numbers, and you can see that this number was way bigger than the number for A. Okay, how long does it take each species to double? Well, if we start off with 500, doubling would be like 1,000, right? So the question is, how long does that take? Times 2 to the what power, right? Because this is what's changing, that t value right there, okay? So to double this, isn't that just 500 times 2? Right? 500 times 2 is 1,000. That's doubling right there. So this exponent right here needs to be a 1, right? It needs to be a 1. So whatever that is, whatever this fraction turns out to be, this fraction needs to equal 1. So the question is, for species A, how do I get this fraction, t over 4, to equal 1? What number do I have to plug in here for t to make this equal 1? And the answer is 4. 4 divided by 4 is 1. So in this case, t equals 4, that's 4 days, to double. Right? So that's for A. And then for B, it's the same thing. Right? We want this to equal 1. We want 2 times t to equal 1, because that's how we know when it's doubled. So 2 times what number? Like what number do you have to put in here to make 2 equal 1? It's kind of hard for people to like wrap their brains around that. So what I like to say is just use algebra, right? You can draw our train tracks and undo what's been done. Divide by 2, divide by 2, and you get t equals 1/2 of a day. 1/2 days, or 12 hours if you want. And that's how you get this to equal 1. 2 times 1/2 equals 1. Okay, hopefully that helped. Remember, email me if you have any questions about anything else or any other questions on any other review. Okay, good luck, Marlene.